We're on the last section of Unit 2 called Transposing Formulae. Transposing formulae is probably one of the most important sections in your whole course. So I'm giving it 3 stars for very, very important. What do we mean by transposing formulae? It's like solving an equation. The difference is you've got an equation, but it's got a lot more variables, at least 2 variables, but usually even more. And then the one that you want to learn is sort of hidden inside of that equation somewhere. And because it's variables and not numbers, it's just a bit harder to think. You've got to know your rules very well in order to get it all the way you want it. So let's have a look at x squared equals 25 minus 36y squared. And the question is not going to say solve for x, but solve for y. So you can see the whole term containing the y is over there, and we first have to get this whole term separate on its own. So we're going to bring this whole term across the equal to. Then we're going to say, well, we don't want the x squared on this side. We want the y alone in the end, so we're going to take this one across. Right, so bring the negative 36y squared across. Then it becomes positive 36y squared. Keep the 25. Take the positive x squared across. It becomes negative x squared. Right, we're peeling off the layers of our onion to get to the y alone. So the next step, we cannot do the square root to get rid of the y squared. We first have to get rid of the 36. Right, on the right we have 2 terms, but they are unlike terms, so we can't add them, we can't simplify them, so we just put the whole thing over the 36. So on the left we are now left with a y squared equals this. So our next step is going to be get rid of the y squared, because we want y equals. Well, the opposite of a square is a square root. So we're taking the square root of this whole thing as it is. And here, important, I can't simplify further. I cannot say it is 5 minus x over 6. You cannot break the square root over different pluses and minuses. So I just leave my answer. This is the way my answer looks. Let's look at another example. Similar, but the other way around. Now I start with the cube root. And in this case, I want to find the value of x. So again, I've got to peel away the layers bit by bit. The first thing is the cube root. So the opposite of cube root is a cube. So if I take a cube both sides, on the left I will have y cubed, on the right the root will disappear. Right, what do we want? We want the x alone. So the term with the x in, let's hold that there. Let's bring the 1 to this side, so that I have y to the 3 minus 1 equals 3 over x. Now, very important. Remember, you can't take away the 3 on the right and leave the x hanging at the bottom. You have to take the x, which is below the line, across. So you first have to get rid of the fact that you have something below the line. If it's below the line, it was dividing. If I take it across, the opposite of dividing is timesing. So it's x times everything I had on the left. Now, don't multiply the x into that bracket. We want the x alone. We don't want it mixed up with everything else. Right, how do I get it alone? Well, if I take this whole bracket and I divide it, they will cancel. But then I have to do the same on the right. So final answer, x is 3 over y cubed minus 1. I'm going to do one more example, and I really suggest that you practice as many of these as you can. They are very important, and it is a whole lot trickier than just solving for equations. Right, in this one, the question is again going to say solve for x. But now notice that both terms on the left have x's. So it's not a case of taking one of them across. And we don't like them underneath the line, but we don't want two terms. So step 1 on the left is find a common denominator. Well, I need an A and an X and a B. But we like to write them in alphabetical order, and they're all multiplying, so the order does not matter. Now we go back. When I had 1 over AX, what did I have to multiply it by? By AB. So at the top I have 1 times B. Plus the second one, 1 over BX, I multiplied by an A. On the right-hand side, we just still have equals 1. Now here comes the nice part. Yes, we don't want a fraction, but we actually just want to get the x out. We want the x to come across. So we don't need to take the AB across because it is one term. They're all being multiplied. So I can keep the AB here and just take the x across and multiply it by 1. Now when I have an equation, it doesn't matter which way round I write it. So whether I write b plus a over ab is x, or x is b plus a over ab, either way round, that's my final answer. Right, you can see you have to go back to your BEDMAS rules. You have to go back to your rules about terms. You really have to know all your math up to here in order to be able to do this one.